Okay, so welcome to the second part of 8.1 where we were talking about relations, functions, domain, and range, and we had just discussed what a function is. It means our x values can't repeat. So in example 3, they gave us each of our ordered pairs, and we were looking to see do they or don't they repeat. And you could easily see, oh, we have repeating 5s, not a function. But in example B, none of the x is repeated, so we do have a function. Now, often though, in real life, or in real math, I guess you could say, it's not going to be feasible for them to give us every single point. Instead, everything that we're going to be working with will be able in some way or another to be modeled by a graph, which we're going to be analyzing. So in this case, in blue I have some coordinate planes drawn, and then in red is like a function or an equation, actually, rather just a graph. We're looking to see if it is a function. Now, notice every point is not identified on this red line. It's not possible to do that, but yet we still have to figure out whether it's a function or not. So there's something known as the vertical line test, and I have a vertical line here. So I'm going to take this, and the idea is, as it says right here before we go ahead, if you can find a vertical line passing through more than one point of the graph, that means our red line, then the relation is not a function. So just like before, we don't want any repeats, same here. We don't want this vertical line to cross that red line in more than one spot at any point in time. So here's what I mean. I'm taking this vertical line. It's passing over. At the moment, I'm only hitting my red line in one point. It's never going to hit that red line in more than one point, and I get all the way to the end and I'm done. And notice there's arrows showing that it keeps going, but still, even if it keeps extending up, it's only going to hit in one point. Now let's carry my graph over to here. And this is a little bit hard to model on the computer because I don't have my finger to point to anything, but so far I'm good. I'm only hitting up here at the top where my arrow is. Now, as soon as I got to about here, even here, I'm hitting at this point, and this point on my red line. So all it takes is 2 points at the same time, meaning it's not a function. So even though right here it's okay, or here it's okay, if there's anywhere where it's hitting in more than one spot, not a function. So the second one isn't a function. If I carry it over here, we have a seemingly straight line, and notice it's never hitting in more than one spot. That is a function. So what we have found is we've been able to look at it, and using our vertical line test, yes, this was a function, no, this was not, and yes, this was. So you can use a vertical line, your pencil, your finger, whatever the case may be, to test that out. All right, last two examples, just to bring it all together. They want us to represent the relation as a graph and a mapping diagram, and then tell whether the relation is a function. So I'm going to go in and label my coordinates, my axes rather, and put a 0 in for the origin. And I'm going to plot the points. So for part A first, I want to plot 0, 3, 1, 2, 2, negative 1, 4, 4, 5, 4. If you want to go ahead, try this part on your own, and then check it with me and see if you're getting the same points. It's easy to mix them up. Some people said that they learned whenever they first learned how to plot points that you have to get into the elevator before you go up. That's an excellent way of thinking about it. Airplane has to go across the runway before it flat takes off. Whatever it may be, you have to do the x first and then the y. So 0 left and right, up 3. 1 over on the x, up 2. 2 over on the x, down 1. 4 over on the x, up 4, and 5 over on the x, up 5. I'm sorry, this is 5, 4. 5 over on the x, up 4, like we have marked. Okay, and then we have to make a mapping diagram. So we have to make two rectangles. Ooh, a little sloppy there. First one's our domain. You can abbreviate it with a D. The second one's our range. Abbreviate it with an R if you'd like. And we need to fill in our domain and range. So my domain are all the x values, 0, 1, 2, 4, and 5. None of them are repeating, and they're already in order, which is nice. Then we have our range, 3, 2, negative 1, 4, 4. Our 4's repeat, so we don't want to count those twice. So we're just going to do negative 1, 2, 3, and 4. Notice I put them in numerical order, and now we can map them from one to another. It goes 0 to 3, 0 to 3, 1 to 2, 1 to 2, 2 to negative 1, 2 to negative 1, 4 to 4, and then 5 to 4. Okay, they asked us then lastly to figure out whether or not this is a function. I can look a couple of places. Do any of my x's repeat? 0, 1, 2, 4, 5? Nope, it is a function. I can do a vertical line test here. I could take a line. If I hit any of these points, taking my vertical line across in more than one spot, nope, I wouldn't. It's a function that way. And then on a mapping diagram, we didn't look at that, but if you can get anything that looks like a less than sign, it's not a function. So we don't have any of those here. We have some crisscrossing. And this is like a greater than sign, and so in a certain respect, but no less than. So all systems go, this is a function, yes. You want to write more than just yes. I guess I was taking a shortcut. You want to make sure that you identify it is a function. All right, let's try letter B. We're going to plot -2, so left 2, down 1. -2, -1. 0, up 2. Over 2, up 3. And left 2, -2, down 4. All right, so then we want to make our mapping diagram, the second thing they asked for. I'm just going to write D and R for range, domain and range. My domain is -2, 0, 2, -2. So actually just -2, 0, 2. We don't want to repeat them if they repeat. My range, -1, 2, 3, -4. So -4, -1, 2, and 3. I'm putting them in numerical order. Now I'm going to map them to where they go to. The first is -2 to -1. Then I have 0 to 2. Then 2 to 3. Then -2 to -4. Okay, so let's check. Do we have any repeating x values? Whoa, we do, -2. So right off the bat, not a function. But let's just use our knowledge to show how we can see it on these other ones. When I take my vertical line, if I were to have a vertical line like my cursor, whoa, right here, it would hit this point and this point at the same time. Even though they're not connected, it hits more than one point at the same time, not a function on there. And then here we have that less than sign that I was talking about, so not a function. So multiple ways of proving it. Nice job, guys.